Assalamualaikum warahmatullahi wabarakatuh. My name is Fasya Surya Nugraha. I'm from the class of TI 2030 from the study program of Informatic Engineering. And here I will expression the final exam task for the algorithm and data structure that being lectured by our lecturer, Mr. Muhammad Ihsan Tahir, MCOM. Okay, let's get started. My final exam task is about this table of content from this presentation will be first is binary search, bubble sort, quick sort, trees, and graph. Okay, now we will go into the content. First, binary search. What is a binary search? Binary search is a searching algorithm for finding an element's points in a sorted array. In this approach, the elements is always searched in the middle of a portion of an array. Binary search can be implemented on a sorted list of items if the elements are not sorted already. We need to sort them first, of course. Okay, this is the example. If we use kind of this, define the binary search array is now kind of this, and then if we run the code, the output will be element expression at index 1 and total step is 2, because here are the arrays. We need to print the element expression at index 1 and the total step. If else, it's not found. So the output will become like this. Okay. Next, the next one is bubble sort. What is bubble sort? Bubble sort is a sorting algorithm that compares two adjacent elements and swap them until they are in the intended order. Distract them open over air bubbles in the water that rise up to the surface. Each element of the array moves to the end in each iteration. Therefore, it is called a bubble sort. The example of it is we define the bubble sort into this array and we need to count the loop count. This is the example I made. All of this kind of code, lots of code, and we need to print all number of loops in data 1 and in data 2 and how much it is the loop and store the data in descending order. This is the output. Loops in data 1 is have a 15 loop and the second one is 32 loops. This is the data if ascending order from the smallest to the highest, of course. Next is the quick sort. What is quick sort? Then from the previous bubble sort and now quick sort. What is quick sort? Quick sort is a sorting algorithm based on the divide and conquer approach where first an array divided into sub-array by selection of pivot elements. Elements selected from the array. While dividing the array, the pivot elements should be positioned in such a way that elements less than pivot are kept on the left side and elements greater than pivot are on the right side of the pivot. The left and right sub-arrays are also divided using the same approach. This process continues until each sub-array contains a single element. At this point, elements are all sorted. Finally, elements are combined to form a sorted array. This is the example of the quick sort in Python. Okay, we need to find the definition of partition array, low and high. Kind of this, the pivot is array is the highest, the iteration is low means small. Kind of this all of this code, and if we run the code, it will output the unsorted array from this x72106 296. If the unsorted array is 9 if it's sorted in its chaining order using the quick sort, it will be kind of this. Okay, next is a trace. What is a trace? Trace is a non-linear hierarchical data structure that consists of nodes connected by edges. Other data structures such as arrays, linked lists, stack, and queue are linear data structures that store data sequentially. In order to perform any operation in a linear data structure, the time complexity increases with the increase in the data size, but it is not acceptable in today's computational world. Different data structures allow quicker and easier access to the data as it is a non-linear data structure. It's about like tree, so it's called trees. Okay, next. There are lots of trace terminologies, like node, an entity that contains a key or value and points to its child nodes, an edge, a link between any two nodes. Root is the topmost node of a tree. Height of a node is the root node or the depth of the deepest node. Height of a node is number of edges from the node to the node. Height of a node is the number of edges from the node to the deepest leaf. Next is the degree of a node, the total number of branches of that node. The forest is a collection of disjoint trees is called forest. This is an edge, this is a node. Okay. Next, this is type of tree. First is binary tree, second binary search tree, and FEL tree third, and fourth, and the last one is B tree. Okay, we go to the tree traversal. What is tree traversal? In order to perform any operation on a tree, we need to reach to the specific node. The tree traversal algorithm helps in visiting a required node in the tree. Traversing tree means visiting every node in the tree. You might, for instance, want to add all of the values in the tree or find the latest one. For all this operation, we will need to visit each node of the tree. Linear data structure like arrays, stacks, queues, and linked lists have only one way to read the data. But a hierarchical data structure like tree can be traversed in different way. Like this. When lots of code are made. We print it and boom. The output is pre-order, in order, and post order. Or it starts from in order, sorry. It's in order, the pre-order here, and the post order here. That's also be printed. Okay. Now the last one. The last one is graph. What is graph? In data structure, of course. A graph in data structure is a nonlinear data structure consisting of vertices and edges, representing connection between data points. Graphs are mathematical structures that consist of nodes, also known as vertices, and the connection between them, referred to as edges. This structure enables the representation of intricate and interrelated relationships. Okay, let me show you the code of mine. Wait, where? Uh, this one. Okay. I already write all of this random data. There's lots of coding. And if we try to run, I already ran it first, but if we try to run it, see, this is A, B, C, D, and A, B, C, D connected. Because the find graph, we need to find the path from data from A to B. Let me show you a picture of it. See, there's a path from A, B, C, and D. If we try, if we want to count from A, B, C, and D. This is the normal path, right? So the path is will be A, B, C, D. But in this one, we need to find the all path is applicable. In this case, there is A, B, C, D, and A, C, D. Wait, what happened to my computer? Okay. Connected. A for the shortest path is A, C, D, and the longest path is A, B, C, D. Okay, connected, I guess. So that's why the path is A, B, C, D. This is the graph that I trying to make. Okay, next. And thank you for all of your information. Wassalamualaikum warahmatullahi wabarakatuh.